right, in this lesson, our objective is you're going to solve rational inequalities algebraically, and then we will check them graphically. So, just for starters, a rational expression, whenever I ask a pre-calc student what a rational expression is, nobody can answer. So here we go. A rational expression is a ratio. So it has a ratio. It's basically a ratio of polynomials, p of x over q of x. The only stipulation is q of x cannot be equal to 0, and that's going to be important when we solve this inequality today. So a rational inequality, you have to solve for the numerator and denominator. For the intervals. So for example, in a quadratic, we had a times b. We looked at that product, and the product, the signs of the two factors in the product determined whether the entire product is positive or negative. Well, the same thing could be said about a rational expression. The same rule applies. The sign of the numerator and the denominator is going to determine the overall sign of the quotient. So the work is similar to solving a quadratic inequality. We just have to be careful with the denominator because it cannot be equal to 0. So we'll list out some steps first, and then I'll work through an example or two. The first step is you want to move all your terms to one side, so you have everything on one side, the 0 on the other side. The second thing you'll want to do is to obtain a common denominator, so you're writing your expression as a single fraction. Then you're going to solve the numerator and the denominator to get the intervals, just like you did with the quadratic. With the quadratic, it was factors of a product. Now we're looking at, I don't know if you want to call them factors, but the factors of a quotient. And then finally, you're going to use test points like you did with quadratics to check for the overall sign of the quotient so that it matches your inequality. Okay, so I'll walk through this example. We have 1 plus x over 1 minus x, and that's greater than or equal to 1. The first step is to move the 1 to the other side, so I have a 0 on the right. So if I subtract 1, I have 1 plus x, 1 minus x minus 1, and that's greater than or equal to 0. The next thing I need to do is to get a common denominator. And that means I need to multiply the negative 1 with 1 minus x over 1 minus x. So both of them over 1 minus x. So I'll do that step. 1 plus x, 1 minus x, minus, and then this is 1 minus x over 1 minus x times 1 over 1. That's greater than or equal to 0. So when you do that, because this is subtraction here, you got to be careful. You're distributing that negative in here. So this is going to change sign. That's one of the biggest mistakes I see. Okay, putting everything over a common denominator, I have 1 plus x minus 1 plus x all over 1 minus x. So I combine, I have 2x, and the 1's add to 0, so I just have 2x, and this is greater than or equal to 0, over 1 minus x, and that's greater than or equal to 0. Now we can solve the numerator and the denominator and set up our intervals. So I know 2x, if that were equal to 0, then x would have to be 0. 1 minus x for my other transition point, if that were equal to 0, then x would have to be equal to 1. But just remember with this guy, my denominator can never be equal to 1, so that's going to come into play when we do our intervals in the end. So my two transition points are 0 and 1. I'm going to set this up just like I did with the quadratic. And then I want to figure out my test points here. I can use -1, 0.5, and 2. And now I'm testing my numerator and my denominator to see whether they are positive or negative. So when I use -1, the numerator is going to be negative. So let me write that. The numerator is going to be negative. The denominator is 1 minus a -1. That's going to be positive. So that overall quotient is going to be negative. And if you look up here, I'm looking for a positive. I want my answer to be positive, so that's not what we're looking for. 0.5. 0.5, if I substitute in the numerator, that's going to be positive. 1 minus 0.5 is also positive, so my overall quotient is positive. Same thing for 2, it's going to be positive. 1 minus 2 is negative, so that's negative. So my answer is going to be in the middle, okay? But this is where we have to be careful. I can include the 0 because that's in the numerator. I cannot include the 1 because that's in the denominator. So if I were to just graph this, it would be a closed circle at the 0, an open circle at the 1, and then you would want the values in between. So this is going to be square bracket 0 to 1 rounded. That's your solution. Okay, let's look at this example. Now, please do not cross multiply to solve these things. You can't do that. You have to get one side equal to 0, get a common denominator, and use your test points. So I'm going to move the 2 over x minus 1 to the other side by subtracting it. That's going to give me x minus 2 over x minus 1, and that's less than 0. Now I need to get a common denominator. If I multiply the first term here by x minus 1 over x minus 1, it gives me x times x minus 1 minus 2 all over x minus 1, less than 0. X squared minus x minus 2 over x minus 1, less than 0. I can factor, and that's going to be x minus 2, x plus 1 over x minus 1, less than 0. So I'm going to have multiple intervals here. Let's find the transition points. Let's see, x minus 2. So I have a transition point at 2. X plus 1. I have a transition point at -1, and then the denominator, I have a transition point at 1. Remember, this one has to always be an open circle. We can't have a 0 there. So we're going to put these on our number line and test out our intervals. If it'll let me, hold on, let me draw this. And I have -1, 1, and 2. Okay, the video probably jumped up on you. Sorry, but I needed more room here, and it wasn't letting me do it. Test points, -1 will be -2. This will be 0. This will be 1.5. And then we have 2. I'll do a 3, I think. Not 2.5, but 3. Because you got to test everywhere. So we have an extra interval here. Okay, at -2, I can look at this, and the first factor is going to be negative, because we got multiple factors here. Actually, I'm going to list them down here. It might be easier. I have a factor of x minus 2, x plus 1, x minus 1, and then the overall quotient. So for x minus 2, it's going to be negative. For x plus 1, when I substitute -2 into x plus 1, -2 plus 1, that's still going to be negative. -2 minus 1 is negative. So then I have to go through, and I got to say, well, a negative times a negative is a positive times a negative is a negative. So the overall thing's negative. So it gets a little complicated. 0 is a test point. Negative, positive, negative. So these two make a negative and a negative make a positive. 1.5, It's going to be negative, positive, positive. So this is negative. A negative and a positive is a negative. Finally, 3, let's see, 3 minus 2, that's positive, that's positive, that's positive. So that one's going to be easy, that's all positive. So I need the intervals where everything is less than 0. So I need the negative intervals, which is going to be this guy, and it's going to be this guy. So if I'm looking at -1, I don't have a problem. Actually, everything's going to be open circle here because it's just less than, so I don't want to confuse you. Open circle, open circle, open circle. Okay, so my answer is going to be -infinity up to -1, rounded, union with the interval between 1 and 2, 1 and 2, rounded. Okay, again, this is a graph in Desmos. I just want to kind of show you what it's doing here. I replaced the 0 with a y so you can see the actual function part of it. And again, I'm only looking for the values on the x-axis. So it goes from -infinity up to -1, dotted, so it's not inclusive. This here is not inclusive. What this represents is a vertical asymptote. So that's still not inclusive, and it goes from 1 to 2, and again this is dotted. So again, you can see, you can use Desmos to see and check your work to see if you're doing it correctly. And that's going to be it for the video lesson. We'll do a few more of these examples in class.